2037 minimum number of moves to seat everyone. This Java code calculates the minimum number of moves required to seat students in given seats. Explanation 1. Instead of sorting the arrays, we create two arrays, seatCounts and studentCounts, to store the counts of each seat and student position, respectively. The size of these arrays is 101 since the positions range from 1 to 100. 2. We iterate through the seats array and increment the count in seatCounts for each seat position. 3. Similarly, we iterate through the students array and increment the count in studentCounts for each student position. 4. We initialize total moves to keep track of the total number of moves required, and seatIndex and studentIndex to iterate through the seatCounts and studentCounts arrays, respectively. 5. We start a loop that continues until either seatIndex or studentIndex reaches the end of their respective arrays. 6. Inside the loop, we check three conditions. If the count at seatIndex is 0, we increment seatIndex to move to the next seat position. If the count at studentIndex is 0, we increment studentIndex to move to the next student position. If both seatIndex and studentIndex have non-zero counts, we calculate the minimum number of moves required by taking the minimum count between seatCounts seatIndex and studentCounts studentIndex. We multiply this count by the absolute difference between seatIndex and studentIndex to get the total moves required for this position. We then subtract the moves from the respective counts in seatCounts and studentCounts. 7. After the loop ends, we return the total moves as the minimum number of moves required to seat everyone. The time complexity of this optimized solution is O(n), where n is the length of the seats and students arrays. The space complexity is O(1), since we use fixed size arrays of size 101 regardless of the input size. This optimized solution avoids the sorting step and uses counting to calculate the minimum moves efficiently.